August 1st. Yes, it is August 1st. And some people survived DEF CON, some did not. We don't know the final count on how many people will never return from the desert, but, well, you just don't know. We haven't seen Paul since he went out there, so, it could be one of those things. And you all know what happened to Joe Pesci. But anyway, we're here with SDL. Today we're going to talk about the mystery, the deep, dark secrets of network addresses called subnet masks. So hang around on SDL.
This is a Security Weekly production.
Welcome to Secure Digital Life. And you type in AAA porn or whatever it is you're typing in. I'm sorry. I was at a PG show.
And I'm really excited to be here.
I'm glad you're here because somebody needs to know what's going on.
That's right.
Okay, so
now somebody has to drink this.
I think it's another day. It's another episode.
Yeah, he's looking at the wrong camera.
You put my camera over here. Cut. Basically, forget you ever saw that. I think actually forgetting you ever saw that would really be a good idea at this point. August 1st. It's August 1st. DerbyCon is the next one. So DEF CON is over. And DerbyCon is next. So that's September 24th in Louisville or Louisville. I don't know. I'm sure they say it's Louisville. Yeah, I know. I've been there. It's Louisville, Kentucky on the 24th, or the 20th to the 24th. I know. It's like Tuesday after DEF CON, and I wasn't even there. So imagine what it would be like if I had been invited. Wild West Hackin' Fest, the next one we're going to be at. So that one's in Deadwood, South Dakota, 27th to the 29th of October. But there's actually training before that, so don't forget that there's training on the front end of Wild West Hackin' Fest that's cheap. I mean, go check that out. I was like shocked and dismayed, and like just was standing there with my mouth open, like, oh, when I saw what they were charging for training. Guys, come on, you can charge more than that, but maybe not. And so we're here. I'm here with Russ, who's back, and he's rejoined us, and he's back again from wherever he was this time. But we're all here, and we're going to talk about the mystery of subnetting. It's like 5 pounds of binary in a 8-bit. No, that doesn't work. Okay, whatever. We're going to talk about subnetting. So I've been threatening to talk about this for a while, and I finally got up my nerve and had to take laudanum or something this morning so that I could live with it. This is the single most dreaded topic in networking. When you take a CCNA course, when you take an N+ course, when you take any of these courses, this is the topic the instructor's dreading covering. It's the topic you're dreading taking, and it's the part of the Cisco exam or the N+ exam or whatever exam you're taking that you're probably dreading, because when you get to the subnetting questions, that's where everybody just tanks the whole thing. Even the CISSP sometimes has like subnetting-esque questions on it. And when I used to teach that, we had to talk about it. And when you just say the word subnetting, people running for the exits, screaming and things like that. I dread covering it in class. And you cover subnetting?
Cover a little bit, basic. I have a nice infographic that we'll share with our audience next week, and that's the simplest that I, the most that I cover.
Yeah.
Simple
okay.
Way, so.
Well, we cover it because the CCNA covers it all the way from 0 to 64, and basically what that means is that there are real simple subnets, like what are called fixed length subnets, and then there's these really sophisticated ones, which are called variable length subnets, that are the ones that give everybody fits, because they turn into story problems, and people and you'll see these things on the CCNA exam or whatever exam you're taking, where they say things like, you need 34 networks that have 100 hosts apiece. What would be the optimal subnet? Optimize, and you have to do these like math story problems that I like, but most people don't care for. And if you ever learn how to do it, if you can learn how to do it in binary, you can do any of those problems and just be laughing at the exam. You'll literally laugh out loud at the exam because you're so happy because everybody else over there with sweat running down their face. There's like a pool of urine underneath their chair. And they're wishing they were dead. And instead, you're sitting there chortling to yourself going, I can't wait to get to the subnetting part. Because I'm always like that. So that's just like my little personal, like thing. It's like, I'm so happy I get to do subnetting today. But we're going to talk about subnetting a little bit, get introduced to it, then we're going to spend some more time on it. Before I forget, though, on next week's show, we are going to record an interview with Congressman Langevin, who's the co-chair of the Cyber Caucus for the United States Congress. and he's a really sharp guy. And he was at DEF CON. I don't know if you saw him at DEF CON. He was tweeting pictures, and I saw a picture of him doing shots. So now we have no mercy any longer, Congressman. So when you're on the show, but we've got you now. We have the goods. But so we want to talk a little bit about what subnetting actually means, and what does subnetting mean to you, Russ? What do you think about it?
I mean, if you want to talk technical, it's when you're taking a public-based IP and then splitting it off into different networks using private IP addressing and stuff like that, and then like you're separating out networks from one to the other. So
subnetting is really it's a part of an IP address, and people forget that. So they start talking about IP addresses, but the truth is that IP addresses are by themselves don't mean anything. They have to have a subnet mask associated with them. And I know you've seen this stuff. So when you look at your computer, or you look at you type ipconfig in Windows, or you do any of those kind of things, you've seen an IP address. If you pay attention, you will also see a subnet mask. And the most common one says 255.255.255.0. And you've probably seen those. You've set those up. I've had network administrator people, literally, in companies, tell me that it has to be that. And I was like, what? No, it doesn't. Yeah, it does. It has to be that. And I was like, no, it doesn't have to be that. And what that is again, it's 32 bits, just like the IP address, but it's very important that you understand it's bits. That the bits are what really matter in subnet masks, not these decimal numbers that we've used for pathetic humans. You know who you are. But it's actually a representation of the 8 bits in each of those octets. And they're being used as flags. So because they're flag bits, what is happening is they are used to determine a very, very critical part of layer 3 networking, which is what network segment is this a part of. And then again, those are CCNA type questions. So you'll see this question, are these two IP addresses in the same network segment? So these masks have to be considered when you look at IP addresses. And the most common one is, of course, just that 255.255.255. That's called a fixed length subnet. And fixed length subnets are where you use all of an octet. So if you have a 255.255 or a 255.0.0.0, those are all fixed link subnets. Now you see something weird, and maybe you've seen something weird, like you see 255.255.224.0. That is called a variable link subnet, and that is a whole different ballgame. And when you get into variable link subnets, that's where you get into these complex kind of problems. And that's what we want to try to get you through. So we're going to try to teach you how those things. We're not going to do variable link today. We're just going to do fixed link subnets. Yeah, I was going to make Russ do one of those problems right now. I've got a whiteboard down here. I'm going to reach down and go, okay, Russ, go. You got 2 seconds. But we want to know what network something belongs to. That's what a layer 3 device, a router, actually does. It doesn't care about the host. So every IP address has a network portion and a host portion. And the network portion of the address is determined essentially by which bits in the subnet mask are turned to on. So if those bits are turned on, then those are part of the network. And the layer 3 devices care about it. If they're turned off, zeros, then the layer 3 device ignores that part of the address and only looks at the network portion. Now, layer 2 then worries about all the rest of that stuff out there. So when you talk about switching and all those kind of things, if you go across a network segment, so if you are on 2 different network segments, when you cross network segments, you must have a layer 3 device between those 2 segments. So that means that a router has to be there in some form or fashion to connect 2 layer 3 segments together. So if you're at home, and you get that little router sitting at your border, like we've shown you on the show before, and you're connected to Cox or Verizon or whatever you're connected to. On the outside of that device is one segment. On the inside is a different segment. And that means they have to have different addresses. So they have to have different network addresses, and the layer 3 device knows about those addresses. And if you have more stuff plugged into it, all those things have to be on separate network segments, and all that is determined by that IP address. So in those typical ones, what happens is you've got 3 octets, so starting from the left, so you got 255, 255, 255. That means all those pieces above it in the IP address are all set on the network segment.
So each octet is 8 bits, so it's 8 bits plus 8 bits plus 8 bit. That would be a 24-bit mask.
Right. So that's a 24-bit mask. And if you actually have heard people say CIDR, CIDR, that is where instead of writing 255, you write /24, which tells you how many bits there are on the mask. And that's a more common, actually, way to write those today. Cisco still won't let you put those in like that, but a lot of systems will. So instead of actually putting in 255.255.255, you can put /24, and it will actually write that out. So when you see weird ones like /19 or /30 or any of these kind of strange ones, and you will, especially use my networks, I just can't help myself. I have to overly complicate things. Those are those variable length subnets again. But if you see /24 or /16 or /8, those are different network styles. So in the very basic piece of this, we talked a couple of weeks ago about Class A, Class B, Class C networks. And the tradition is that Class A is a /8 255.0.0.0 mask. And what that means is that you have a network address, so like 10, and each network can have 2 to the 24th minus 1 hosts in it, which would be kind of nuts. I mean, maybe in the future sometime that we will need things like that for, if I have my drone swarm is flying all around my head to protect me from harm, I may need, that many local host addresses. But typically you don't have that many hosts in a single segment, and so you would tend to break your networks up. So then you could go to a Class B. So in a Class B, you've got a /16 or 255.255.0.0 is a mask. So now that address, 172.16 or whatever, becomes the network, and you've got 2 to the 16th minus 1 host addresses out there in that last piece, which is 65,535 addresses in those last two fields. So you might see some of those. Even that is a lot of addresses for a single network segment. I mean, have you ever set up a network that big?
Not that big. No, Class C is usually what I'm doing.
And that's why most people, most of the time, what you're going to see is a network that is 255.255.255, which means you've restricted the first 3 octets. So whatever numbers are in that part of the IP address. So if it's 10.1.1, then that is that network segment. And then that last little octet, which is 8 bits, which is 255 hosts. So 2 to the 8th minus 1, 255 hosts in that last segment would then represent, a pretty reasonable network segment. And that's what most people are using. So what that means then is 10.1.1 is the network segment, and that last piece, .1 or .50 or .200 or whatever it is that you've got on your laptop is actually then basically the host portion of that address. Does that make sense?
Yeah. Should we put it into perspective? Like, who would use a Class A, who would use a Class B, and who would use a Class C?
Sure.
So a Class C I can start with because we use that at home. Like,
Right.
it's just a small network. It's not many, 2 to the 8 minus 1 number of hosts, so it's not very big. So a small home, small office type network.
Right.
So what about a Class B?
Well, the tradition, we talked about it a couple of shows ago, the tradition of a Class B was that it was reserved in the original 60s documents for universities and mid-size enterprises that would be out there. And what you have to understand is that go back, not that long, we don't have to go back to the 60s, you can go back to the year 2000. And in the year 2000, it was very common to have what is called a flat network. So you would literally see a university campus that would have all one segment, which means every single computer in the entire university, which was like 8, could all see each other. And that was an early security problem that emerged because you would see these campuses where you could literally sit down with Nmap. And I remember, I was using Nmap back when it was called Satan. Because it was originally, the name of Nmap was Satan, which stands for System Administrator's Toolkit for Administrating Networks. And when they originally brought that product out, you could run this port scanning device across the entire university campus or the entire corporation because it was called a flat network, which would have been like a Class B. So they would have 65,000 public addresses. We at the University of Northern Colorado, where I used to work, they literally had a Class B network, and they would have 65,000 addresses that were all in a single network segment, which means that a hacker or even just a curious person, not a bad guy, or it could be a professor of cybersecurity or somebody like that, could just literally go out and map the entire network and say, well, there's the president's office, and there's the president's computer, and there's the mainframe, and there's the email server, and you could see the whole thing right there. And as security started to evolve, those things became a big issue, and they started segmenting networks. And so we started breaking our Class B network into multiple Class Cs. So we extended that subnet mask on out from 255.255 to 255.255.255. And suddenly we had a whole pile. We had 255 networks in the third octet and 255 hosts in each network. So we could actually break it into tons of different subnetworks and bridge them together with layer 3s. The reason they didn't do that was because routing cost so much money. It was brutally expensive, and they used hubs. So they used old hubs, which are just sort of forward everything.
Yeah, everything, not just individual.
And like I say, I don't know. I would guess a Class A network back then, if you had a flat network, they were theoretically reserved for governments, giant corporations
Maybe
like Raytheon, telecoms, or whomever. And so you wouldn't have seen those kind of addressing structures being put out in public. But very quickly, of course, that became a problem with security because people started running probes, and we were seeing all kinds of attacks that came out on our networks even way back then, and it was a bit of an issue. You want to add?
No, I think that. So why do people use layer 3 devices?
Well, layer 3 devices have to decide where the traffic goes, and so the way a layer 3 device works with a network, and that's all it cares about, is it looks at the subnet mask, it determines what the network portion of that IP in the destination field of a packet is, and then it says, do I know where that is? So every layer 3 device has what's called a routing table in it, and in its routing table, it knows about things that are directly attached. So if it's a network that's plugged into it, it knows about it. If it's got an interface that has that IP network segment on it, then it knows about it. It knows about things you put in there. So you can put stuff in a routing table yourself, and you can do that on your Windows computer too. I mean, if you have a Windows computer or a Unix computer or whatever, a Mac, and you've got 2 network cards in it, or even virtual network cards, you could literally say, these packets go that way, and those packets go this way. I do that at my house all the time because I have traffic that needs to go to my school network, and I send that out over a private VPN, and I have traffic that's just my stuff going out. I want to watch Star Trek on Netflix. I don't want that going through my school network because I don't want to tie up all my traffic with that. So the layer 3 device has to make that determination. If it doesn't know that, and it looks at that network address and it says, I don't know you, I don't have any instructions about what to do with you, it does what's called dev nulling. And so it black holes the packet and just drops it, and it goes away. And if you start building some of these networks in Packet Tracer or GNS3 or some of these other cool products that you can get now to play with, you can actually set some of this stuff up and see how that happens, and you can build it up pretty quickly. So routers then have these routes, and all that ends up being critical, because if a packet arrives at a router, so it's your home, and that router says, I don't know you, it's going to dev null the packet, and you may never see it. So if you don't have a route to whatever it is that you want to route something to, then you're not going to get anything. My example for that, then, I had a pretty big example of it. If you had a network and it says 172.16.32.55, and if you want to see these, I wrote these in the show notes so you can actually see them online if you want to check it out. So 172.16.32.55 using a /24 255.255.255.0 address, basically the network then is 172.16.32. So any layer 3 device would sort that out for you. It would take a look at that and it would pull it together. .55 in that example is the host portion of that. So that the router doesn't care about that one bit. And it all comes down to where those bits are turned on and where those bits are turned off. I mean, does that make sense?
Yeah, it's very clear.
Okay. So basically then, if you have DHCP turned on, we talked about that last week, so if you have DHCP turned on, DHCP is assigning you these things, but it's still assigning you to a network segment. So one of the most important things then for you to know about this, just at this level, is, am I in the right network segment? And this is the place where a lot of your networking problems are going to start at home. If you decide for whatever, and I've consulted on these, if you can imagine, there's somebody called me and they said, our network quit working, we don't know why, and you go look at it and you see 172.16.32. If a device is on 172.16.33 with a /24 subnet, that is in a different network. And that means that there would have to be routing in between those two networks, or the devices cannot communicate. So if you're sitting there, even if you're sitting at a table like we are right here, and you got a laptop sitting on the left and you got a laptop sitting on the right, and they have different network segments, there would have to be a router somewhere to allow those two devices to communicate with each other, because if they're otherwise they won't work. So you need to be able to look at those addresses. Like I said, this is the most common kind of schema, this /24 stuff, and you see this all the time. All your home routers default to this. So they're but I will tell you, they're basically putting all the people in your house in the same network segments. If you go around and look at all the devices in your home, all your Internet of Things devices, your Alexas, and I will say my cats don't like Alexa. I have an Alexa in my room now, and I always say, Alexa, turn the lights out, and the cats all jump up because they don't like when Alexa says, okay. Her voice really bothers them for some reason, so she apparently has some kind of sound that sounds like something that eats cats or something like that. Any other things you want to add to this?
No, I think it's great. And no questions online either, so it must be pretty...
Oh, slow day. You guys should jump in there and ask questions.
But we had 9 people, so...
But I will tell you, if you're watching, what we're going to do with this and where this kind of goes is we want to expand on this so that you really understand it. So the next subnetting show, I'm going to actually have us sit down and we're going to do some subnetting work to show you how this actually works on paper or on the screen, so you can actually see what's going on and start making these determinations. And then the show after that, we might, if I really get up my nerve, we could talk about variable length subnets, because variable length subnets are terrifying. And students struggle with these unendingly, and they're very, very challenging till you get the hang of it. If you ever get the hang of it, it's really, really easy. And it really is like riding a bike then. It comes right back to you. One last thing to say before we depart today. If you have questions you'd like me to ask Senator or Congressman Langevin, post them to us, and I will ask. We're going to tape that because we can't do it. We're not going to do it here. We're going to do it at his office, and we're going to tape it. So if you would like me to ask him some kind of question, and it's not highly inappropriate, or if it is, go ahead and send it in, and I'll decide. But remember, I'll forget, and it'll be on the screen, and I'll be like, so how many? But be sure and send those in so I can ask him your questions too if you have them, because I'm going to interview him next week on the 9th, and we'll have that show up for you. But next time we'll talk more about this. We want to dig into the subnetting thing, because I really want you to understand it, because it's not that hard. It just seems that way. And if you ever get the grasp of it, you can really pull that together. Russ, do you have any other
I think this will
that?
Probably go like 3 or 4 shows maybe. I mean, it could.
It's super nasty, and eventually it gets down to these things, and this is in honor of a student. If you're out there watching, there's a student from a long, long time ago, not even in Rhode Island. It was a student so long ago it was in Colorado. His name was Travis, and to this day, I still call these things Travis nets. And Travis nets are where he was obsessed with the idea that what if you turned on bits not in these nice sequential orders, like you turn on the first octet and the second octet. What if you just turned on every other bit? And he said, would it work? And I said, sure. The layer 3 device will still figure it out. It's just now the decimal numbers make no sense at all. So determining what's in a given network is really, really challenging in a Travis net, but it would still work. And he was obsessed with this, and he did so much work on trying to figure out all these strange networks that you could come up with where you have all these really bizarre subnets. And to this day, so that's probably like, 15 or more years ago, that Travis was obsessed with the weird subnetting that I still to this day call them. It's on my syllabus in my class. It's called Travis nets, and people are like, "What is a Travis net?" I'm like, "It's you don't want to know, because they're really, really squirrely." But you will see stuff like that out in the real world, and I have seen really strange things. The most common one I saw was where someone set the network up, died. Or left. Died was pretty common, and nobody knew why the network was set up that way. I consulted on one once, and they had a subnet mask, and it was 225 or 255, 255, 248, 255, 255, 248.0, and they didn't know why. It was just, the guy said, look, just don't mess with it, because if you mess with it, nothing works anymore. The whole network comes crashing. We tried setting it to 255, and it didn't work anymore. And I'm like, well, no, it wouldn't. You'd have to change the IP structure.
Wow.
He was like, you actually know what that means? And I was like, yes, I do. And for just this small sum, I will tell you exactly what it means. Anything else?
No, I think.
Okay, so next week we will talk about the real nitty-gritty of the mystery of subnets. Send your questions in for Congressman Langevin if you have any, and we will see you then. Thanks for tuning in.